Day 1 of the radicals and rational functions unit. So radical function has the form of y equals the root of f of x, where f of x is some function. If you want to take the square root of a number, it's only defined for non-negative numbers, so it will be defined for 0 and positive numbers, and your domain is going to be the set of values of x for which f of x is greater or equal to 0, or your domain would be from 0 to infinity if we're talking about y equals the root of x. Now I'm just going to graph our standard root x graph and also y equals x. So your y equals x is just a linear line. It looks something like this. The slope of 1, and that's y equals x. Now if I want to draw the y equals root x graph, I'm going to take all my y values from the y equals x and take the square root of it. So the square root of 1 is 1, so that remains the same. The square root of 0 is also 0. Here we can't take the square root of these values because they are negative. So I'm not going to bother. It starts from here then. Then for our next value, the square root of 4, which is located over here, is going to be 2. So then you have a point here. And you would continue the process if you wanted to. And that's what your y equals root of x graph looks like. You could have also used a table of values to find your points. So if you want to plug in x equals 0, that's the root of 0, which is 0. X equals 1, that's the root of 1, which is 1. And then you probably don't want to use 2 because we don't know what the square root of 2 is unless we have a calculator, but you do know what the square root of 4 is. So if x is 4, then your y value is going to be 2. And you can continue on with that process to find more points if you want to. So our shape looks like kind of like a half of a parabola on its side. That's always the shape of what a y equals root x graph, or y equals the square root of some function graph, is going to look like. So some properties, we're going to mainly just focus on the root x graph. Your domain of this graph is from 0 to infinity. Your most left point is 0, and we touch it, which is why we have a square bracket, and then it goes on to infinity. Your range, your lowest y point is 0 when we touch it, and then it goes on to infinity. We also have an x-intercept of 0 and a y-intercept of 0 for this particular graph. Now let's say that we've been given another function, and it's also a linear function, and we want to draw the graph of the root of f of x. So this is our f of x graph, but we want to draw the square root of it. Whenever you need to draw something like this, we're just going to follow the certain method and how to do it. There are things called invariant points, and these points won't change from your f of x graph and your root of x graph. And they occur at y equals 1, because if you take the square root of 1 for your y value, you're still going to get 1. So that point doesn't change. And the other one are points along the x-axis. So we are going to graph these first. So my y equals 1 is located here. That's one point that's going to be on the root of f of x. Another point is points along the x-axis. We have 1, which is located here. And that's it for step 1. Step 2, you're going to find a point. And when I say point, I just really mean the y value of it, to take the square root of. So if we see a point here, there's a 3, but the problem with that is I don't know what the square root of 3 is unless I had a calculator. But I do know what the square root of 4 is. It's 2. So what I'm going to do is draw a new point with the same x value, but just a new y value at y equals 2. Step 3 is to connect the points. Your starting point is going to be the point on the x-axis. So that means I'm going to go with this point here, and then I'll connect it with all my other points. I'm going to extend this a bit because this does go on forever. Notice I don't have anything for below the x-axis, is because if I took the square root of any of these values down here, then I'll be taking the square root of negative numbers, and we can't do that. So just as a side note, graph will not exist. Square root of f of x will not exist under the x-axis. Before we're done with this question, we're going to state the domain and range of the root of f of x. Okay, so your domain then, our most left point is negative infinity. Our most right point is located at x equals 2. Our lowest point is 0, and then it goes on to infinity. So I want you to try the next one on your own. Try to follow those 4 steps that I have, and then I'll go through the solution with you. Okay, so you've been given another linear graph. The first thing you're going to do is graph the invariant points, which is on the x-axis and at y equals 1. Your next step is to find a point that you can take the square root of, and it looks like we can take the square root of 4 here, which is 2. Remember to keep your x value the same. Then we can connect these points and extend. And that's it for that graph. And if we want to find the domain and range, the domain is from -2 to infinity. Our most left point is -2, and then our right point is an arrowhead, so it goes to infinity. Your range is going to be from 0, because that's our lowest y value, and it goes on to infinity. Just a reminder that nothing's going to exist below the x-axis for our square root of f of x graph. Let's try to do this with a quadratic function. So we want to find the square root of f of x, and we're going to use the same rules. So your first step is x-axis values stay the same, and so does your y equals 1. So I'm going to graph that right away. So we have one here, have one here, have one here, and have one there. Now you're going to find a y value you can take the square root of. In this case, we see that we have a y value of 4 at our vertex area. So if we take the square root of that, that's going to be 2. The square root of 4 is 2. So you keep the x value the same, and then you're going to draw your point at y equals 2. Then now we can connect our points. Remember, nothing will exist below the x-axis. Just as a side note, take a look of how I graphed our sides here. So you need to be careful on how you do this because they are picky about this on the provincial exam. When you have values going in between in decimal and you take the square root of it, it actually becomes slightly larger. So if we took the square root of 0.64, this would be 0.8. Okay, so your values get slightly larger for your decimals. That's why I draw slightly above our original graph. And as your side note here, root of f of x does not exist below the x-axis. So your domain is going to be from -4 to 0, because if you look at our graph, our most left point has an x value of -4, our most right point has a value of 0. Then your lowest value for your range is going to be 0. That's our smallest y value. The largest y value is going to be 2. So go ahead and do the chart yourself, and then we can go through the solution together. Okay, so for this chart yourself, we're going to follow the same steps that I have just above. So we're going to graph all the x values because those stay the same. So we have one here and we have one here. And we also are going to graph the y equal 1 value. This one's slightly tricky because when I take the square root of some y value, I can keep doing that forever. So we are going to have arms that tend toward positive and negative infinity. But this middle region here doesn't exist in our new graph because it's below the x-axis. Okay, so I'm going to pick on either side of those arms something you could take the square root of. So if I look at y equals 4, I know the square root of 4 is 2. So I'm going to graph this down here. And remember to keep the same x value. And now we can extend this graph and connect the dots a bit. It's going to look something like this because it does go on forever. Then you do the same thing for the other side. So if you take a look at this point of y equals 4, we can take the square root of that, and that's going to be 2. And we're going to keep the same x value. And we're going to do the same sort of thing. Connect our points and extend. So that is what your graph looks like. Notice again how I drew this piece of the graph, that it goes slightly away from the original graph just because, again, if we take the square root of a decimal, we're going to get a slightly larger number. So I'm counting for that, for where I put those arms. Okay, let's do another example now. We're going to sketch the graph of the square root of f of x, given that f of x is a cubic function. The same principles are going to apply. So we're going to do the same rules as what I stated before. The first thing you're going to do is draw in your x-intercepts because those will be the same. Now we're going to find whenever our graph is y equals 1, looks like it would be 1 here. And this one doesn't seem like it's going to reach it, so I'm just going to leave that alone. And this region here does not exist because it's below the x-axis. So we're just going to ignore those arms. So I have this one to worry about then on this side. I just need to find points that I can take the square root of. So I'm looking at this one here. I can take the square root of 4, which is 2. So that's my new point. And then we have another one at 9, which is over here, and take the square root of that, which is 3. And then lastly, we have one here. You can take the square root of 16, which is 4, and try to keep the same x value. So this is what your graph is going to look like. And we're done with that section of our graph. Now we have one more to consider, and it's this one here. So if I take the square root, again, of decimal values, they're going to become slightly larger, just slightly. So I'm going to draw this just above our original graph, and that would be it. So again, this section here won't exist because we can't take the square root of negative numbers. Finally, I'm going to state the domain. So your domain is going to be from, I'm assuming this is maybe -1 and -2. So this will be from -2 to -1, inclusive, because those are points. And we have a point at 1, and it goes on to infinity. For your range, we're going to say it's from 0 to infinity. Your lowest point is at 0, then your highest is determined by the arrowhead. And going back to that chart yourself, you didn't state the domain for this one. So your most left point is an arrowhead. Then we're going to stop at around -4.5. And that is the point. So I'm going to close that off. And then it starts again at 0.5. But then our most right point is just an arrowhead, so it goes on to infinity. Your range is going to be from 0, because that's your lowest y value point,